I say a bit of projectile motion here because projectile motion is a large, pretty extensive subject. It's not covered much on the MCAS, but a little bit is. So I need to talk about it a little bit. So here I will do that. Now, if you throw a ball and throw it in this direction, say like the red arrow, you know what happens. It goes in this kind of pattern, doesn't it? Up for a while and down. It's going forward too, isn't it? We call this kind of shape here a parabola. You'll see that in math next year probably. So you see parabola, say, oh yeah, Mr. Kent mentioned a parabola in physics. It travels like this in a parabola. Now, as it does this, the ball is moving vertically up, then down, and it's also going horizontally, isn't it, forward? It does both, doesn't it? Let's dispense of the horizontal motion real quick here. Once the ball leaves the hand, there's no horizontal force. Now, while the ball's in your hand and you're pushing it forward with your hand, you're definitely exerting force on that ball, aren't you? Once you let go in this direction, there's no vertical force at all. The hand's no longer pushing on it. There could be a little air resistance, but we're going to ignore that. It's tiny. Okay, so it really, going forward, there is no force. Now, what did Newton's second law tell us about that situation? Well, first of all, Newton's second law said force causes acceleration. But another way we said we could word it was no force, no acceleration. So there's going to be no acceleration in this direction if we ignore air resistance. So no acceleration. So horizontal velocity this way is not going to change at all. No acceleration. Horizontal velocity doesn't change. But that's not really what we're too concerned about here. We're more concerned here about vertical. Now, what do you think? Is there any acceleration vertically? I'll give you a clue. Let's say when it leaves your hand, it's going up. I'm just talking about vertical now. It's also moving this way, but let's say it's moving up at 5 meters per second. How fast is it moving up right at the top? Think for a second. Come on, use your head. How fast is it going vertically at the top? Well, right here is where the ball turns from going up to going down. So really for a brief second there, it's got a velocity of 0. Right at the top, it's not going up or down. Its velocity is 0. So here's what's happening. If we start at 5 meters per second down here, at the start, there it is. At the top, vertically now we're talking, okay, only vertically, it's going 0. Didn't it slow down vertically? Sure it did. It's going pretty fast and slowed down by here. And by the way, on the way back down, it speeds back up, doesn't it? In any case, up and down, it definitely accelerates, doesn't it? Can you see it vertically? There definitely is acceleration. Now here's the question. Because of Newton's second law, there must be a force causing that. What's that force? What force causes the ball to slow down on the way up to 0 and then speed up on the way back down? Think of it as a downward force. Hope you got it. It's easy. It's gravity. In fact, what happens here on the left-hand side, it's going to start at 5 and at 0. Gravity slows it down, reduces the vertical velocity. Over here, it speeds up again, actually back to 5, where it started at, and gravity increases the velocity, doesn't it? So that's the force that causes this acceleration. So when a ball is tossed or anything is tossed in the air, it travels along a parabola like this. Horizontally, if we ignore air resistance, it doesn't accelerate at all. It's just some constant velocity. But vertically is very different, isn't it? It slows down on the way up, speeds up on the way down. That means there must be a force doing that, and that force is gravity. Okay, here's your video code. Please write that down. You'll need it. Bye.